pleased to introduce Chris Meacham, who will be giving us a paper entitled Constraint Accounts of Laws. Thanks, Chris.
All right. So, it's sort of bundle, sort of mainstream or popular accounts of laws. There's a couple of categories. On the Humean side, if I need to be louder,
A little bit.
like raise the roof or something, I'll know if you can be louder. On the Humean side, the most popular option by far is sort of a best system analysis account. On the non-human side, you get a couple of sort of necessitation relation accounts, like Armstrong and other people. You get sort of dispositional essentialist accounts, like Bird and people like that. You get things like primitive local dynamics accounts, like Tim Laughlin's account. And then recently, there's a sociological fact. In the last a year, there are 3 people who have independently proposed a different kind of non-human account. So Emily Adlam, Eddie Chen, and Shelley Goldstein, and me. I'm going to call these primitive global constraints accounts. So what's a primitive global constraint account? So here's how I'm understanding. These are accounts which maintain the following things. First, that the world has primitive mnemonic features. All of these things. Well, as primitive mnemonic features. The world, these features are sort of global. So they work at the level of the world as a whole. And these mnemonic features constrain, but they don't do anything more than that. So they do more than just describe what the world is like. It's not human. But they don't, say, engage any highly asymmetric notion of production or generation or anything like that. Okay. So why should we care? All right, so there's a couple of reasons why I think these accounts are interesting, but I think the big advantage of these accounts compared to the other sort of mainstream accounts is, unlike those accounts, these accounts can accommodate the varieties of mnemonic possibilities and laws that physicists and scientists have taken seriously. So I won't go through this in detail, but obviously best system analysis has the issue of not being able to recognize a lot of models of various theories. Necessitation relation accounts have problems sort of recognizing laws like the past hypothesis, conservation laws, functional laws, and there's stuff to say about each of these, but it's hard and it's messy. Dispositional essentialist accounts actually have problems with the same 3 things here. And primitive local dynamics accounts have problems with non-dynamical laws, like the past hypothesis, and problems with retro-causal laws, or causal solutions to relativity. Constraint accounts, by contrast, have no problems handling any of this. A big motivating push for all the authors is capturing all these different kinds of laws people have wanted to propose. Okay. So then there's this interesting question, or interesting if you're, at least if you're one of these 3 people, which I am, you might be like, so there's these 3 different independent proposals. How are they similar? How are they dissimilar? What features of them should make us like one more than the other? And that's what this talk is about. So first I'm going to sketch these 3 constraint accounts, as described. I'm going to talk through 6 differences, 6 ways in which these accounts differ from each other. And I'm going to end with a completely impartial and unbiased assessment about the relative merits of these accounts. Okay. So the first proposal is Emily Adlam's proposal. So we start with the idea of a Humean mosaic with a distribution of local categorical properties. And Emily suggests that we associate, sometimes they mean identify, laws with probability functions over these sets of Humean mosaics. So these laws basically say, hey, well, so functions that only assign trivial values, the non-probabilistic laws, these are laws that say, hey, the world has to be a member of one of these Humean mosaics, or the world can't be a member of one of these Humean mosaics. And functions that assign non-trivial values yield probabilistic values. Those values are the chances. And on Adlam's account, there can be many different functions at the same world. So it's multiple laws that hold at the same world. So Chen and Goldstein's account, so they take laws to be primitive facts about the world. These are very sort of hyper-intentional, fine-grained facts. They have something like sentential form. They're not completely clear on this, but they do commit themselves to, for example, the laws referring to particular properties. And laws having, say, particular logical forms. There's a hyper-intentional movement. And take non-probabilistic laws to pick out a set of models. Pick out a set of models that the world has to belong to. On the slide. There. What about probabilistic laws? So here, they offer 5 different proposals for how to understand probabilistic laws. So I'm going to talk through 2 of them, because only 2 of them are compatible, or only 2 of them allow all of the usual sort of non-human nomic possibilities you might want to accommodate and figure out. So I'm going to focus on those 2. One of them says, okay, there's this distinct batch of constraints for probabilistic laws. You have some constraints to be the non-probabilistic laws, and you got some other constraints to be the probabilistic laws. The other proposal they considered is maybe we should posit a primitive gradable constraint notion, goes maybe from 0 to 1. And then you can use that to characterize both probabilistic and non-probabilistic laws in a way similar to the way Emily Adams gets. Non-probabilistic laws are what you get when your primitive gradable constraint gives you all 0 and 1s. Probabilistic laws are what you get when you get sort of in-between values. Okay. Finally, there's Meacham's account. Now, here's your person. Finally, there's my account. So, here we start off with some ordered triples. There are 2 propositions in the world. Think of A as antecedent, C as a consequent proposition. Maybe at the end of the day, you might want to think of this really as a triple of properties at its ID, but put that aside for the purposes of this talk. And then here's the fundamental posit of the theory. The theory claims that there's a fundamental nomic likelihood relation that holds between such triples that satisfies certain constraints, certain nomic axioms. That's the proposal. Intuitively, you're wondering how to read this nomic likelihood relation between triples. You can basically read it as A given C at W is at least as nominally likely as A prime given C prime at W. That's the trigger. Okay. Then once we have that, we can provide a representation uniqueness theorem showing that there's a unique way of assigning numbers to these triples between 0 and 1. And assign the status of being nominally required and nominally forbidden. As it lines up with the nomic likelihood relations. Lines up meaning roughly that higher numbers are assigned if and only if a triple is deemed more nominally likely. It shows that this resulting assignment will be a countably average probability function. And then the rest of the account sort of follows up this. So identify complete laws, basically with the property of being a world with certain kinds of nomic likelihood relations. We can characterize the status of being nominally forbidden and nominally required in terms of triples that this theorem tells you to get assigned those statuses. Likewise, you can determine the chances using the numbers that the representation of the uniqueness theorem. That's the third proposal. Okay. So what are the differences? What sort of things might pull one way or another? But here's one difference. So we ask the question, is there an objective way to carve the complete laws into individual laws? So is there, like, for example, a right number of individual laws? For an Emily Adams account, yes, there is. There are 7. There are 7 fundamental laws, or 4, or whatever. That's a right number. The number of functions associated with the world. So the right answer to this question. Chen and Goldstein are agnostic. I know, but I asked them, and they're like, eh. So, okay, they're agnostic. And on my account, there isn't any way to carve up the complete laws and individual laws. Sort of structurally, it's set up such that I can see it's very difficult to get anything like that, but it gives you account of the complete laws. Say anything about how you might divide it up into special laws. Certainly no privileged way of dividing up into particular individual laws. So is this a good thing or a bad thing? I think it's both, depending on your tastes. So here's a perk of following Emily allowing for this carving out is you can make sense of certain kinds of inegalitarian claims about laws. So like Mark Lane, for example, has suggested that maybe some laws are more modally robust than others. Maybe conservation laws are more modally robust than forest laws. And Emily can easily make sense of claims like that, right? There's individual claims, and some of them can be more modally robust than others. Whereas in an account like mine, and there's no way of carving complete laws into individual laws. Trying to say that some of these are somehow more robust, more modally robust than others, is they're hard to make sense of. On the flip side, what might make you favor denying as a way of carving these up? But you might be pulled by certain kinds of skeptical intuitions. For example, take the classical formulation of Maxwell's equations in terms of electric and magnetic fields, right? And there are 4 Maxwell's equations. And then we're just talking about Griffith's stuff. Need Griffiths will find us. And then you can also do a bit from zero. You can reformulate it in terms of electric and magnetic potential. You get 2 equations. So one thought is, what's the right number of laws there? Are there 4 laws or 2? So one thought is maybe, I don't know, there's an answer. Or you'd be like, what? Surely there's no fact of the matter. Whether there's really 4 laws there or 2, or 1 or some other number. If you're pulled by those skeptical intuitions, then you might want to deny that there's an objective fact that are carve up the complete laws. Here's a second difference. So, to make the laws be fine-grained. For example, can we distinguish between otherwise identical laws that refer to different properties, have different logical forms? So, Ken and Goldstein say yes, that's a very fine-grained account of laws. As in both Adam and I say no. Or kind of have this coarse-grained picture of laws, relatively speaking. Again, is this a pro or a con? Again, I sort of think it's both, depending on what sorts of things pull you. So here's a perk of a fine-grained account. Is there are certain kinds of distinctions that some people have suggested might be around, which a fine-grained account can recognize. So here's an example. If you look at retrocausal laws, there's 2 ways you might think about it. One is as sort of dynamical laws, where you have dynamics going up towards the future and dynamics coming down from the past. Here's another way you might think of sort of retrocausal laws is there are constraints, maybe time symmetric style constraints on what the world is like as a whole. Here's the law. Here's the law. Now if you think, man, it seems like those are actually 2 different laws, 2 different ways the world can be, then you can make sense of that. If you have something like Chen and Goldstein's fine-grained picture, you can take those to be different laws. Whereas in Emily and I have to say, no, those are just the same law. You can't distinguish between those. On the flip side, why might you want to deny this? Well, again, there's certain skeptical intuitions that might fool you. So take the law, suppose it is a law, that all emeralds are green and all sapphires are blue. But imagine the same law but described in terms of blue and green. So is that a different law? So on Chen and Goldstein's account, okay, we're referring to different properties. So this is just like a different law. But you might be pulled by that, like, what? Sure, this is not a different law. Like, this is just the same law expressed in terms of blue and green. So there's no fact of the matter to show whether that law is really referring to green and blue versus blue. If you feel that intuition, you might want to say, here's a third difference. So it's natural to think that these laws and chances are probabilistic and non-probabilistic laws are of a kind. So intuitively you might think, what do probabilistic laws do? They say, hey, given a certain state of affairs, there's a certain likelihood of another state of affairs coming about. And non-probabilistic laws do the same thing. It's just you turn the likelihood all the way up, right? Given a certain state of affairs, this other state of affairs will definitely come about, or maybe will definitely not come about. But it seems like they're of a kind. They're doing the same kind of thing. It would be nice if one's account could capture that. So all these accounts, can they capture that? So an Adams account, yes. Adams account, probabilistic and non-probabilistic laws are the same kinds of things, right? There's both functions assigned sets of Q mosaics. What distinguishes them is just the different values, kinds of values they assign. But they're the same kind of thing. My count, likewise, story is slightly more complicated, but the representation theorem takes the normal likelihood relations and then spits out values and non-requirements and non-forbiddings are sort of the same kind of way, sort of unified way. So they're talking about the same kind of thing. What about Channing-Goldstein's account? So here it depends on how we understand the probabilistic laws. If you understand probabilistic laws as these sort of distinct, separate constraints, then no. Right? So non-probabilistic laws are given by one kind of constraint. So you have these separate, distinct constraints, and these are probabilistic laws. So they're just different kinds of things. Think about a gradable constraints picture, but you start with this primitive notion of a gradable constraint. If you go this way, then we can figure out time. Because primitive gradable constraint, the only difference, as with Adam's account, is on what sorts of constraining values they assign. Now the fourth question. Does being not required distinct from having a chance of one? So this is another feature that you might want. You might think that these things are distinct features. So, for example, what's the chance of at least one of infinitely many coin tosses landing heads? That is a chance of one, but it's not non-required. All the coins could land heads. And the accounts capture this distinction. So, my account can. The difference between non-requirement and having a chance of one. Every non-requirement will have a chance of one, but not vice versa, as it turns out. Adam's account can't do this because the Adam's account, the difference between probabilistic and non-probabilistic laws is just what values they assign. Something that assigns values of just 1 and 0 ends up being non-probabilistic. So it ends up giving you no requirements. Adam's account can't draw this kind of line. How about Channing-Goldstein's account? Again, it depends on the picture of probabilistic laws we adopt. If we take probabilities to be given by distinct constraints, then yes, we can. We have one kind of constraints, give the no requirements. We have these distinct constraints, give the probabilistic stuff. And so they can definitely come apart to this kind of. Whereas if we buy this gradable constraints picture, gradable constraints, then we can't make distinctions. The same reason that Emily Appen can't. It's interesting to note for difference 3 and difference 4, each of these two understandings of Channing-Goldstein can get one of these things, but not the other. Give up either being able to distinguishing non-equal requirements and having a chance of one, or give up being able to say that laws and chances are unencumbered. Let's see. Two more differences, and at this point I've just veered from any semblance of fairness and really sort of lobbying in favor of an account. So you might ask, what vindicates our numerical assignments to chances? If somebody says, hey, the chance of heads and tails is 50-50. Somebody else says, no, the chance of heads and tails is 60-40. I think that, no, one of these claims is correct. What makes that claim correct? Here's one story. You might say, oh, what makes it correct is there's some fundamental relation between, say, chance events and the number 0.5. That's what makes it correct. Okay, but that's crazy. Crazy for a bunch of reasons, but one of the reasons it's crazy is, our use of numbers between 0 and 1 to measure chances is arbitrary. If these numbers between 0 and 2 or 0 and pi. So it can't be like a relation between an event and the number 0.5 that's really doing some sort of metaphysical work. Here's a better sounding answer. You might say, okay, look, chance events have a sort of quantitative structure, quantitative metaphysical structure, and that structure is particularly represented by numbers. That sounds pretty good. But of course, if you can tell that story then, and you're giving us an account of laws and chances, you want your account to tell us what the underlying quantitative structure is. You want to tell us how exactly, you show us that does in fact vindicate the numerical assignments we made to chances. So these accounts do this. So my account does. There's no likelihood relation. Vindicate the numerical assignments to chances. So to show this in the representation uniqueness theorem I mentioned earlier. Adam's account doesn't. Again, so for total, we have a function that assigns we have a probability function over sets of King mosaics. I don't know if you think of that as like a group linked numbers. The probability function is group linked numbers or what have you. We're certainly not given any story about it. It's a happy story. life is intending goals to happen. They're not giving me some happy story about what that vindicates or explains our numerical assignments and chances. So last, what constraints are there on laws and chances? So there's various sorts of constraints which intuitively might be walkable in laws and chances. So there's a bunch of examples, but here's one. You might think, for example, that chances at different times should be related in certain ways. I mean, it's not the case that, the chance at one time and the chance at another time just totally throw the that would be bizarre. You expect them to, for example, maybe be defined over the same algebra. So maybe expect to be able to get one from the other by conditionalization, just given certain circumstances, and so on. It'd be nice if constraints like this and other kinds of constraints sort of fell out of one's account of laws and chances. So an algorithm telling goals to account, again, because there's sort of quietness about the details, don't give you any of that. Don't tell you anything, impose any constraints on what chance distributions, different chance distributions that a world have to be like or how they have to relate or anything like that. Whereas in my account, does in fact. So a bunch of these constraints you might want to put on laws and chances can derive as theorems. Once you buy the primitive, the no likelihood relation that satisfies certain constraints. So for example, you can derive that chances at different times will indeed be related by minimization, and derive that something can't have a non-trivial chance and be non-locally required, and so on. Okay, conclusion. So the most popular accounts of laws, I think right now, have problems accommodating a lot of the known possibilities and laws that the scientific community takes seriously. Whereas these constraints accounts we proposed recently can accommodate these. So I think I'm all for team constraints. I think these make the most attractive, some of the most attractive options on the market. They're all very attractive options. But if I had to choose, well, like gun to my head, I'd note that of these constraint accounts, so my account is the only one that vindicates our numerical assignments and chances. The only one that yields the kinds of constraints and laws and chances that we typically take for pain. And the only one that can both treat laws and chances as of a kind and distinguish known requirements for units and having a chance of 1 or 0. So I like my account best. All right, that's it.
Thank you, Chris. We have comments by Mike Hicks.
All right, great. Thanks, Chris, for a really interesting paper. I have seen some of these developments in the constraint account of laws, and I've been kind of like watching with interest. So I'm glad to like get to talk to someone about it, about these accounts. These accounts, I'm going to talk a little bit about the accounts in general, and I'm going to offer some criticisms that I hope Chris can respond to of the overall project. I have kind of fewer criticisms of the comparison that Chris has raised here, but I think that by comparing these accounts, we've got kind of nailed down some details of the accounts which I've seen lacking in the other papers on constraint accounts. So the accounts are united in claiming that the world has primitive nomic features, these features are global, and that these features constrain the world, but don't do much else. A worry that I've consistently had about the accounts is that sometimes they seem to want to have their cake and eat it too. So they're kind of quietists about the metaphysical structure of the laws. They don't want to say anything about the metaphysical structure of the laws, except that the laws are primitive. But then they employ the laws in doing important explanatory and metaphysical work. And I've kind of consistently worried that without giving us more details about what the laws are like, it's kind of hard to evaluate whether the laws are able to do the explanatory and metaphysical work that they're required to do by the non-humans. So it's hard to see whether they're up to the task. One thing I've liked about this paper is that Chris has kind of looked at different jobs the laws might want to do, especially sort of structural features you might want to have for the laws and the relations between laws and chances, and asked whether these different accounts have the features that we might want the laws to have. So for that reason, I really enjoyed the talk. Meacham's own account, I think, is more detailed in giving us a metaphysical structure for the laws. So instead of just sort of taking laws to be primitive gnomic features, Meacham says they're sort of likelihood relation between propositions, or towards the end of the paper and in a footnote in the slides, Meacham suggests that they might be likelihood relations between global properties that the world might have. I think that this gives us a more illuminating account of how the laws might constrain the world and how they might have the features that we want them to have than the other accounts on offer. And I also think it's a good idea for Meacham for Chris to talk about the laws and think of the laws as relations between properties rather than propositions. Here's why. One worry I have about the other primitive global accounts is that they seem to take laws to be something like representational entities, right? So on Chin Goldstein's account, the laws seem to be either propositions or facts, but they don't give you a lot of detail about what they take propositions or facts to be. If propositions or facts are sets of worlds, and worlds are mere abstracta or semantic type entities, then it looks like their laws are something like special propositions. Similarly for Adlam, if the laws for Adlam are a function over worlds, and the worlds are kind of mere abstract entities, then it seems like what these primitive constraints are doing is drawing a big circle in the Platonic sphere of abstract entities that we use to represent the world. And it's hard to tell how the location of that circle is going to do a lot of explanatory work about, about determining what the actual world is like, right? So when I've looked at these papers that talk about laws in this very abstract sense, I've kind of wondered, how are those laws actually determining anything in the world? What is the constraint they're talking about? Is it just kind of labeling some mere possibilities as gnomic and some as non-gnomic, right? That's the kind of worry I've had. If Chris takes laws to be relations between properties, that gives us a little bit more structure that might enable us to explain a little bit more about how the laws constrain the actual world or determine what properties things in the actual world have. I also think that it gives us more detail about the metaphysical structure of the laws, which again will allow us to evaluate how Chris's account and the other gnomic constraint accounts, the other primitive accounts, compare metaphysically, so we can kind of compare them to other metaphysical views. Great. So I like to say I think we should go for properties. I have two worries, and these are worries that I have about all the primitive gnomic constraint accounts. First, as we all know, it's the business of laws to govern. And what the laws say goes, goes. If something's gnomically necessary, then it's true. I tend to think, unlike Schaffer famously, that we should have some kind of explanation for why the laws do that is somehow connected to their structure or nature. So when we have an account of what makes something gnomically necessary, it would be nice if that account also explained why the gnomically necessary things are true. Not everybody thinks that anymore, but you might think it's at least a good making feature of the kind of laws of nature if you can kind of squint at it, look at what's making the laws necessary, and see how they're also going to be true. So my first kind of worry, which holds for all the gnomic, primitive gnomic constraint views, including Meacham's, is how are the gnomic likelihood relations connected to actuality? Is this like a merely stipulated connection where maximally likely things happen? Or is there something to do with the relation between properties that the ones that get ranked highest are going to be the ones that are actually instantiated? I think this also is connected to the gnomic likelihood account of chance. So, one would like a reason to expect more likely things to happen even if they're not necessary. Is there some way to make sense of this on the gnomic likelihood account? Honestly, for me, this is the thing that I find most confusing about non-Humean accounts of chance when I sit back and think about them. So for non-Humean accounts of laws, I can see how the laws can force something to happen. What's a little weirder for me is trying to imagine what it's like for something to be more likely to happen according to laws. It's like not being forced to happen, but somehow it's being metaphysically pushed into existence, but not as hard as some other things, right? That's something that I find confusing. I don't think that confusion is irresolvable, and I kind of would like it if it could be illuminated for me. So I think that I wonder if the likelihood relations kind of, in some way, make things more real or more likely to be real. One would hope, I think, that there's some greater degree of oomph behind the things that are ranked higher on the likelihood relation to justify our greater expectation that they're going to occur. Okay, so that's my first question. It's a two-parter. Then my second question is, I worry that the primitive global accounts sacrifice too much when they move away from the more structured pictures, like the Humean picture or the Armstrongian picture, or even the account like Maudlin's that takes laws to be productive entities that take the world at one time and crank out the world at another time. And my worry for this is that the global properties or propositions are really cheap. There are like lots and lots of them. And there's no guarantee that they're gonna, that a maximal world property is gonna be a property the world only has if it's like orderly or allows induction to occur or is uniform in some way. So I wonder, this is just a general worry, whether by removing the metaphysical structure of the accounts, they're gonna fall into a problem that Tyler's raised for Maudlin's account, which is that by removing the structure that you have in like Armstrongian accounts, you lose the connection between laws of nature and regularity. And that loses one of the motivations for non-Humeanism. So one of the motivations, as I understand it, for non-Humeanism is that non-Humeans often think Humeans are inductive skeptics, right? And that by adding in some kind of necessity, you're going to get your way out of inductive skepticism. And maybe that's not a motivation at all for Chris, but if it is, I wonder if you think there's enough structure in the likelihood relations to enable induction to happen. Okay, great.
To reply from Chris.
Yeah, so I'm going to thank Mike for some great comments, and I pretty much agree with pretty much everything. So I'll just answer the questions real quick, or answer as much as I can. So one question, two or three questions. So one was, how are the non-likelihood relations connected to actuality? Is their connection really simulated, or is there some metaphysical reason to think the maximum likely properties are instantiated? Yeah, so my theory postulates fundamental limit likelihood relations that satisfy certain constraints, certain limit axioms. So these axioms entail that maximum likely things are instantiated. So is that a metaphysical reason, or is that stipulated? Both? I don't know. It is sort of built from the axiom that follows from them. But also the axioms are sort of coherent, decisive, metaphysical package, metaphysical story. So, yeah. So, yeah, that's my answer. Both. The further interesting question. So one would also like the reason to expect more likely properties to be exactly that, and more easily or more readily instantiated in some sense. One would like there to be a different degree of oomph behind more likely things, to justify our greater expectation they occur. And there's some reason to think that these known likelihood relations measure oomph. So we're going to think it's going to sort of depend a bit. So every theory has its primitives. The primitive for this count is fundamental known likelihood relation. If you intuitively can get on board with that, understand that, then I think the answer to this question is yes. You can intuitively grab, get the notion of just something is not more likely than another, then that, the representation of these theorems show you, oh wait, and we can in fact show you how to make sense of quantitative. In fact, that's quantitative structure, make sense of something being twice as not being likely as another, and you make sense of oomph and all that, those sorts of ways. So you can grab onto that initial intuition, then I think you can answer the question and say, yeah, my count gives you a way, shows you how things have more or less oomph in that sense. If you can't intuitively grab the positive, you grab the question. That's how it is. And then the last question is, I worry that primitive global accounts sacrifice too much. By removing the metaphysical structure of these other non-human accounts, I worry that primitive global accounts lose non-human distinctive response to inductive skepticism. Does this concern Meacham? Should it concern us? So yeah, right. So I know there are people like Armstrong who think, non-humans are better positioned for problem induction. And then Professor Humans say, humans are better positioned to expect problem induction. And I know there are smart people in this room who have written on exactly this topic. I'll say that I personally I'm personally inclined to think the problem reduction is like a really hard problem, and that no account of laws is going to make it really any less hard. So this is the kind of consideration that really pulls me personally that much. That's all right.
Questions? Z, why don't you start?
Hi, Chris. This was very fun, and so I'm curious about the way that these likelihood relations work. Because you said sort of in response to Mike, oh, this does explain. I mean, though Mike was saying like, what explains the connection between this thing you posited, this likelihood, and this likelihood relation and the world. So well, I posited it as a primitive. And so it's certainly not true that like just seeing the explanation of where our numbers come from, where numerical assignments of likelihoods come from for your primitive thing is going to explain. That explains where the numerical assignments for that primitive notion come from. But it certainly wouldn't like. I'm not actually sure. I don't know what the derivation is for your representation of uniqueness theorems, but if it's like a similar one, it's going to be that is the extremal value just going to be the thing which bears only stands only in the right hand side of the more likelihood relation things. That'll roughly.
You're just assuming the chance of one and the not required. Here's a complete aside. So on the representation of this theorem, the two parts of it that make it instantly different than the other kinds of accounts is there's two problems that I work hard to avoid. One is the avoiding the richness assumptions, and you can assume, for example, that every chance of value is tangent to something you normally get. The other thing is being able to distinguish between a chance of 1 is 0 and not required and not forbidden. So none of the standard accounts give you that kind of line. So a lot of the work in my particular approach is having axioms which allow you to be able to pull those two things apart. And so things end up looking a bit different in those accounts. But I think that the gist of the points we're reading are still going to hold, so don't keep on going.
But the concern would be something that like, that if, as Mike's sort of worry is that what, because the worry is something about like, what do these things look like within worlds such that they would actually have anything to do with actual truth, especially when they are not some like maybe necessity implies truth, but when it's not quite necessity, but it's this other thing, and you say, well, I named it likelihood. It's like, okay, Armstrong, right? But like, the concern is something like, you know, oh, well, we have this thing, it bears the more likelihood than relation to this other thing. In what way should we think that that relates to things in the world when we start going and throwing, you know, electrons through our Gerlach magnets, and which way we should be expecting them to go? And it feels like an answer to that kind of question is like one of the things that makes for a good community view. And it's hard to get from the global modal talk to something that can talk about this in the would be, you know, space. So, but I don't know if there's more you can say about that or.
Well, there's more I can say, first of all, but the more I can say that'll be satisfying to you. But here's more I can say. So, right, there's posits a fundamental relation. And I glossed over, because it didn't really matter here, what the gnomic axioms are. There's a layout, there's particular gnomic axioms that are obviously plausible. Those two things together tell you, and just positing a fundamental relation doesn't tell you anything at all about what it's like, right? I told you how many slots it has. That's it. The gnomic axioms together tell you, say, a bunch of substantive things about what this relation is like. So I give you a feel. And this is one of those things, like you might look at, you know, topology or whatever, you sort of look at the axioms and you start to get a feel for what it's like from the kinds of constraints, say, it obeys or has to be. So that's one sort of way of getting a grasp on it. It includes ties to, for example, actuality. Something that will fall out of the axioms. Now, there's still the further question of, okay, you posit this fundamental thing, you've given me these axioms, so I can sort of see how those axioms sort of make it look sort of like likelihood. And maybe you want some ontologically nice story that we should have. I think Mike's right about this. Understand this is a triple of properties. Okay, it's a fundamental relation between triples of properties at certain times. So that's sort of metaphysically what's going on. But how does that make the things likely? And so I think that's fair. I think, having been a student of both Tim Modlin and Barry Lower, I have sort of sympathies to both sort of camps. And I can get myself into the Barry headspace of I just cannot see how necessitation relations or essential dispositions or this gnomic-like motivation tie to things. So it's like they make an explanatory gap in a certain. And so if you can't intuitively get onto okay, I'd sort of from this notion of don't be more likely than. And I think that explanatory gap, at least part of it, is going to remain. I don't think there's any. I can tell you all this stuff about it and how it works and blah blah blah, but those initial sort of explanatory gap will remain regardless of what I say. Just like I think this is true for any non-community account. So there's sort of explanatory gap. Yeah. So I can get you, because that's how far I can get you. But I think there's every non-community account is going to face an obstacle of doing that last step. You either have to have people who buy in and sort of see it or not.
Yeah, thank you. I think I've got similar OSD and microwave. I'm beginning to think that perhaps that is a problem. That's just you do. So looking at these constraint comes the laws, and putting it perhaps a little bit childly, it seems to me that they all describe what the law does, but they don't really offer an account of what the law is. So kind of leaving out some details. Yeah, what the law does, what the law does, it picks up a class of normally possible trajectories. That's kind of the basic view, and then we kind of pick it up a little bit to account of probabilistic cases. That seems to be kind of the underlying basic idea behind these constraint accounts. And then there's what's the law? It's just this class of trajectories. We formulate some different way to get probabilistic stuff. So I would think that, well, that tells me what the law does, but it doesn't tell me what the law is, and then we have a question like what's its Z-base. So is your view that that concern that we're raising kind of misses the point of the proposal? That the extra stuff that we want, an explanation, what makes it the case that these are the trajectories? Let us ask the questions to which there aren't really any good answers because all the other accounts of law suck. So this kind of thing is very thin account of law. This is as good as it gets. And what we all want by extra explanation, what makes it the case that these are the probabilities, we're just trying to revive a hopeless proposal. Is that
Yeah, so I think that's basically right. I mean, I certainly don't think Armstrong's or I don't think any of the other non-community accounts will have more explanatory. Oh, I can totally get that one. Tim, I see your production, but boy, I just cannot see. One thing I will say is this isn't a big thing. One thing which is true of my account is I do tell you what the laws, the complete laws are a property of the world. I can tell you exactly which property it is. And Emily Adlam and Shannon Goldstein are a bit more hand-wavy about what exactly the laws are. I do tell you metaphysically what they are. It's a property. It's a property of the world. I can tell you which property it is. But that aside, I think the other stuff you're saying is absolutely right. Yeah.
Yeah.
I'm curious about the extent to which these views can be generalized and potentially even generalized to encompass some of the other non-community views. And this relates to a bigger picture question about what we're doing when we're giving the metaphysics of laws. Are we describing the laws of this world? Are we describing what it takes to be a law, which might vary between different worlds, things like that. So just thinking about the three conditions that you lay out. So obviously, if you just had condition one, that the world is primitive gnomic features, you're just describing all non-human views. But I'm curious whether you could generalize conditions 2 and 3 a little bit more. So for instance, is there a reason why you think the gnomic features have to be global? Or could you have a more general constraint account on which the world has primitive gnomic features, they may be local or global? And then similarly for the third one, what you're saying that this notion of constraint is fundamentally different than, for instance, and incompatible with, like, Laudelin's notion of production? Or could you have a more general account of constraint on which one way of that things get constrained is by there being this like primitive production relation between the two states. But you don't need to have the production relation. What's important is just some kind of constraint. So those are two suggestions for ways in which you might have like a more general constraint account. And I'm curious whether you find that more general account like attractive at all, or if there's reasons why you think it really needs to be spelled out this way.
Yeah, good. So a lot of the details about the way I spell it out are informed by trying to pick out this class of views versus the other ones.
Yeah.
So for example, I totally agree with the last thing. The constraint, Tim's notion, I think, gives you a notion of constraint.
Yeah, okay, good.
But that's why when I pass out the constraint account, which was like, this constraint does nothing more. So I'm saying, here's how it's different from views like Tim's. It doesn't include any time-based symmetric element. That's a big deal for all three of us. It's trying to avoid, that's what we really don't want to do that. We want to offer retrocausal laws of various kinds. So this is a slightly weird, that's also this weird terminological thing. I'm trying to find a name and label for things that pick out this class of views and that show you how it's distinct from the others. That's why constraint is characterized in the ways. That's not to suggest that other accounts like Tim can't have constraints. So, yeah. And then the second one, that one is that. Oh yes, they have to go right. So that's sort of a distinguishing feature. So that's not a philosophical commitment or something. That's a feature that lumps these together and differentiates it from the other accounts that I talked about. Discussion about how to exactly characterize global. I do have a detailed account of how to do that, which is it's sort of like duplication, being also require the perfect natural properties, the perfect natural properties to automap and perfect natural properties to automap all the way up. So it sort of looks like super duplication. But that's something that doesn't make any sense to you. But that ends up ruling out things like Armstrong and Bird's accounts. They don't end up being. So I don't think it's, there's no commitment or deep reason to be global. That's not the reason. I think the reason all these accounts end up being global. And I think the problem is that these other accounts end up running into, expecting characterizing certain accounts, just comes to the fact that certain accounts of laws are just really hard, maybe impossible to make sense of. If what you're trying to do is say, take two little bits of fundamental local properties and say, okay, stuff in that's going to give you conservation of energy. They're going to give you, the past hypothesis, the initial state of the world, a particular low energy state. And how's the relation between mass and charge going to give you anything like that? It looks like some of the laws that we looked at, seriously, look for all the world like holistic laws. So I think the reason these accounts all end up being global is that no one's been clever enough yet to find. I mean, there's a sense that I can grant it'd be more intuitively satisfying if there was a little local piecemeal built up picture of behaviors. But I don't think anybody's managed to do that.
So in your view, if something doesn't satisfy these three features as written, is it not a law, or is it not a law of the type you're interested in right now?
Oh, just not a law of the type I.
Okay.
Yeah.
Thanks.
So that's a classificatory.
Okay, thank you.
Yeah.
Mike.
I had a question about, it's kind of similar to your worries that Adlam and Chin Goldstein's view can't distinguish between necessity and chance one. But this is more like on the, something that I'm going to say that I think is in favor of a more local view rather than a global view. So in a local view, you have a chance for each chance event, right? And so like you have a chance that each coin flip comes up heads. And then you use the law of large numbers to show that random seeming behavior gets chance one, even though the non-random looking sequences, like all heads, are possible, right? And on your view, if I understand it right, that's just going to be, the chances are going to apply first to the total sequences. Is that right?
No.
Okay.
So the chances will apply first and foremost to the triples. If you think in terms of propositions, or you think in terms of relevant properties, but there will be particular events. The sense in which it's glow, so it is, it's not like
Okay.
some frequency thing and then it doesn't react. It's
Great.
assigned individual things. But the way in which it's applied to the world as a whole is, it's not like, okay, go show me the world, and I zoom in, look at an event, and I see the 0.6. Rather, what Scout does is like, you show me the world, and I see the glorious web of number calculations. I got my calculator. Like, okay, I see. From its place, the web of calculations, I see that natural value to assign is 0.6. It's more numpty likely in these things, and less numpty likely in these things, in this sort of way. And it has this quantitative, and these relations have a certain kind of quantitative structure that allows it to make sense of that kind of thing. Sorry, is that?
Yeah, sorry, so just, I think I have read your other paper on this where you have the axioms, but not recently.
Yeah.
So is the idea like, for coin flips, you'll have a different property for each coin flip coming up heads and tails. And for each coin flip, there will be like a distinct property, and the gnomic likelihood relations will count all of them as being equally likely, or something like that. Like for each coin, it's equally likely to come up heads and tails, and it's as likely as any other coin to come up heads and tails. And then you can do your law of large numbers thing just as you would on that.
Yeah.
Okay, great.
Assuming they have the same likelihood. I mean, my count certainly allows the possibility that over the course of the world, heads become slowly more likely.
Yeah.
And every chance coin has a different, slightly different chance. And that's logically that's possible on my count.
Good. But you do make sense of assigning like local chances and
Yeah.
sometimes. Great. Cool.
Are there other questions? I'm good. I don't know exactly the best way to formulate this. I'm looking at two things. So one, that gnomic features are global constraints, and then also just that these order triples start with a pair of propositions A and C. And so I'm wondering, are there constraints on the types of propositions A and C could be? Could it be like literally any proposition, or is it like, no, these somehow have to be global constraints, like it expressed in terms of generalization? Like, is there anything like that going on, or is it really just anything that?
So the constraints I put on A and C is they can't themselves be about gnomic facts.
Okay.
Avoid certain circularity words.
Right.
I was actually thinking about this, actually I was thinking, talking to David about this, I think as I characterize it in the paper, basically there need to be propositions which can, very roughly, you can characterize it as perfectly natural properties, not including this one. The snowflake likelihood relation is positive. Well, it sort of end up having that effect. But other than that, go crazy. So you can have very weird kinds of propositions in there that you can have chances assigned to.
Okay.
So if you think there are ghosts and you want a chance for this ghost causing a demon to explode, absolutely, those are in.
Okay. Quick follow-up.
Yeah.
So Eddie Chen is sympathetic to the idea that although we've got this primitivist account that there are no constraints, there actually do end up being some further constraints, notably that we pay attention to how simple the laws get, or can be when expressed in terms of natural properties. And he's worried about this because of concerns related to explanation and deduction. Are you sympathetic to those kinds of moves at all, or?
Yeah, sorry. So I should say two things. One directly to that. One other thing I feel I should just say as a responsible person. So Eddie has certain epistemic concerns, particularly like philosophy of science epistemic concerns that are pulling him. And I get that. I'm not like unsympathetic, but as somebody who, Frank Razinius, the subjective Bayesian is a bit strong within me. So it's hard for me to go with the thought that simplicity or crystals of difference or that sort of thing is going to solve our epistemic problems easily. So I'm a little wary of that as sort of far as the epistemic thinking goes. But as far as I can tell, those are completely orthogonal to the metaphysical stuff. That's what we're talking about here.
The way he presents them. I mean, I think he should just build them into physics.
Yes, right. The way he presents it. Yeah, that's right.
Yeah.
And then the thing I should mention as a responsible person is that both Emily and Eddie Chen have independent papers where they offer proposals about how to understand chance. And both of them, there's different ways of describing this, but now describe it as, what are the way to give it more robust account, or you describe it as them losing their nerve. But like Eddie has a paper where he basically gives like a Humean account of chance. Pair with it's a very interesting Humean account of chance, but it's basically a Humean account of chance to pair with a non-Humean account of laws. So somebody who's really worried about the chance stuff, maybe that's actually the right sort of compromise place to go. And I think that's that's where Eddie's heart goes. The chance that it's too weird. They want the Humean account of chance with a non-Humean account of laws. Emily Adam has a paper which is a similar flavor. It still ends up being, I think, non-Humean, but it starts moving in that direction. So as far as so if you want to know what accounts that they actually adopt with the chances, those are the stories actually. They actually have said things. Not ones that answer questions about how chance functions at different time related or any of those questions, but they have said substantive things about. Actually, maybe Eddie. They had substantive things about chance.
There's time for one more question. Anybody would like to get in?
I've been vanquished. I've been vanquished.
Oh, Z, yeah, go for it.
Yeah.
So just wondering, sort of following up on what you said to Mike. So you described that like, oh, well, you can actually get a kind of this sort of, the likelihood facts being about the particular properties, instantiations within worlds. And so, is it compatible with your view for like there be elements of the world that are like unconstrained, where aren't any likelihood facts in the offing? Is there something that is it necessary, either nuclear or metaphysically, that there wouldn't be any of those gaps? Is there something ruling those things out? So it doesn't automatically feel like likelihood would demand that. It was just a measure of relative likelihood.
Good. So that's right. So in fact, the setup is those triples are the kinds of things that the split can hold between when it holds the things, but there are triples which no non-collective relation can hold between. So you can, in fact, for example, have completely lawless worlds, where there's no known facts for standing. And you can have worlds where you have just little bits of known facts. You just have this one little chance event, and everything else is like, ah, or it's like constrained. So all of those are things that my approach allows for. It's certainly not the case that every triple of those forms has to have some known collective division. I only hold between ones that are, as it were, nominally active triples. But it is closed. Once they're nominally active, you do have to have a non-relation to all the other nominally active triples. Does that make sense? Sorry.
Sure. So is there a generality, or is this like hyper-particularist? Like, is this the sort of thing that there's, like, are there laws that govern whole categories of things on this picture? I know you don't, they can't be broken down into simpler on your view, but like, you might have thought that one of the things about laws, maybe one of the things that makes them a useful tool for at least thinking that, well, if anybody were to solve the problem of induction, we're going to probably do it with some leafy laws, is that they apply in this regular way to a whole, all of the members of certain natural kinds. But it seems like your version can either be viewed kind of globally or hyper-particular for each event.
In the sense that you're talking about, it is hyper-particular.
Okay.
So here is something which is possible on. Well, it's tricky, but if you imagine a world which, in some sense, quote, literally true, but in some intuitive sense you might describe as having little patchworks where there's intuitively different kinds of laws instantiated in places, but doing it in some sort of consistent way, that's a kind of possibility which my account allows for, or permits. So it doesn't, and this is exactly the sort of thing Mike was talking about when he said, hey, I let in a lot.
Yeah.
So if, like Tyler, you think, hey, here's a perfect thing Armstrong, you're sort of constrained what you think. In this case, these things hold between pairs, similar properties, and that cuts down a lot on sort of what the known possibilities are. I, along with my other constraints fellows, go opposite direction. I'm like, let it in. What sort of world do you want? Tell me, and I'll give it to you. Yeah.
We are officially out of time. Let's thank our speaker and commentator.